Alright, so I'm gonna do a different experiment with just this coil and a regular long coil. These two coils do have the same amount of copper, or same amount of turns. Other than these, they're just two wires twisted together, and these are just a single coil. So this one's just acting like a jewel thief. This is my MOSFET circuit, my battery, lithium iron phosphate battery. The current charge is at 1325, and got a potentiometer. I'm going to turn that in to increase the or decrease the ohms, so it'll start picking up. Alright, so all I'm doing is just turning this in. Alright, so now it's on. Alright, so that's the least amount of ohms I can, or the highest amount of ohms that I can get this to run at. This is a 40 watt bulb, 120, and it's actually pretty bright. This actually puts out more power than the vortex coil because I think there's just more induction between it. So that's that. Now this is just a 2-inch piece of steel. That's all that is. Shoved inside of this one. And then now that's air core, and it's working. It works better without anything in it. So now watch when I put this near it. It drops. And now when I put it inside, I gotta hold this up. You can see the output is dropping as I put in the iron core. Well, steel core, not iron. So as I slowly push this in, you can see the power go down. Also, the output is going down along with it. So the core is actually making it less efficient at converting power. So that's all the way in. And then there is an output on here. It's not very significant. And when I short this out, you can see there's actually a difference. Actually, the light bulb increases intensity. It actually increases the overall output and power consumption. I didn't expect that. This is a 15 watt, 120 watt, 120 volt bulb. It lights it up dimly. Not significant or nothing, but a little bit. But now when I put that on, it decreases the power or the output to the bulb. You can see that dimly getting, and the output doesn't, or the power consumption doesn't change that much. Although the bulb is still lit versus me shorting it out. For some reason, when I short it out, it actually increases. I'm not sure why it's doing that either. Probably, obviously, it's increasing. Maybe it's increasing the flux on the side. You can see this side is very strongly magnetic. It's pretty strong. This coil's getting hot. Oh boy. That's the one thing with that vortex coil is the coils don't get that, they don't get hot at all really. You can tell there's a lot less of a field over here than versus here. But it does put out more power. So, I don't know. Yeah, it's definitely getting warm. This is not even hot at all. It's ice cold. Alright, let me move that out of the way so I don't break it. Let me pull this out. You can hear the frequency increase too as I pull that out. Alright, now it's out. The bulb is a lot brighter, pulling more power, but not by a significant amount by any means. So this is without the bulb connected. Connected. It's honestly not changing the power consumption at all. Although to just run this, that's a pretty high waste of energy just to run the circuit. So it's not very efficient by any means. But it is interesting when I put a load on, it doesn't increase the power consumption, neither drops it much. Just a slight increase. And that's about it. And if I increase the ohms going through the circuit to the gates of the MOSFETs, that'll decrease the output power and also increase the power consumption. There's actually a sweet spot. And right about there is the sweet spot. That's about where I had it. Hope these are staying nice cold yet. Oh, but the coil's getting hot. Wish I had a ferrite rod. That would be optimal. I don't. I need to get one. That would be kind of nice. Just a piece of aluminum, just to see what happens. Nothing much. Oh, it's kind of neat. I've got myself a bunch of different bulbs. This is a 7.5 watt, 120, 15, 40 watt. I got a 300 watt, and this is a 125 watt. And this one's 25 watt. I got a bunch of them just to experiment with. But I think I'll wrap this up for this video. It's a good demonstration. I kind of like the compact design of this. It's kind of neat, but that is hot. Oh, that is hot. That is unbelievably hot. Most energy is being put into freaking heat. Yeah, that's ridiculous. But nice to see the MOSFETs aren't hot at all. Like there's nothing to them. They're not hot, but there's so many of them. They're able to dissipate the power pretty easily. Alright, well, see you guys later.